All right. Hey, everybody. My name's Serena. I'm one of the Fusion 360 ambassadors. I go to Cal Poly Pomona. I'm studying manufacturing engineering. I've been working with Fusion for about like half a year now, so I'd say it's a pretty easy program to pick up, especially if you have um, experience with other CAD or designing software. So, yeah. And here's Jake.
Hey everybody, so I'm another Autodesk student ambassador. I studied industrial design in college, and I've been using Fusion for a good while now, probably coming up on 4 or 5 years. Learned a couple other CAD packages before that, AutoCAD and SolidWorks. So if you have experience in any other CAD software, transitioning to Fusion will be very, very simple for you. So excited for our little workshop today and to help you guys have success in this design competition.
Yeah. So for our agenda today, we're going to be talking about what Fusion 360 is. We're going to go over the UI, how to collaborate on Fusion 360 with other students, maybe you need to share with your professor. And then Jake here is going to make that model that you see on the right. We're going to make the assembly of the parametric jack stand. And then we're going to be talking about the different Fusion 360 workspaces. So there's about 8 of those, and I'll go through this a little bit briefly. And then we will talk about some learning resources that we have available for you. And then we'll, I guess, maybe open up to questions. You can email us questions, or you can ask us in Discord, since this is, I guess, recorded as well. So, yeah. So Fusion 360 is a CAD software. CAD stands for Computer Aided Design. So basically, you can take some idea that you've maybe drawn up on a napkin or thought of, and bring it to life through Fusion 360. So you can design in Fusion 360. You can basically, do anything that you need to create that model in Fusion 360. So you have all these different workspaces that you can see above here that you can work with as well. And there's different bodies, components, and assemblies that you'll create to create your idea. So these are the different workspaces. So we have design, which is the one you'll be working in, the most. This is where you're going to be creating, your basic model of your idea, and then, working into other workspaces to, bring that to life. Next are generative design, which is our newest workspace. This is kind of where you input different design goals and parameters, and it kind of generates maybe a better design based off of those different parameters that you gave it, and it'll make a better design based off of that. Your rendering workspace is kind of the workspace that you work in to create a photorealistic picture of your workpiece here, and basically that's what you're gonna be wanting to use a lot in your competition here, because you really want to show off your piece to your judges here. So the rendering workspace is amazing for that. You can make really beautiful images through this workspace. Your animation workspace is a workspace that allows you to kind of create exploded views. It allows you to show the actual function of maybe your joints in your piece, and yeah, you can also use it for assembly instructions. Your simulation workspace, basically, if you were to input it's kind of, I guess, a little bit similar to the generative design, where you'd maybe input some information. It'll basically run an analysis, based on some of those parameters, and tell you if your piece would, maybe break at this certain point, or yeah. And then your manufacturing workspace, this is where you're going to be creating your tool paths, and it kind of generates G code through these different tool paths that you'll create. So if you're using a CNC machine, this is going to be the workspace you're going to really work in. You can also use, I think, in the manufacturing workspace, this is where you can work on 3D printing stuff as well. And then your drawing workspace. So maybe if this is a graphics class, this is where you'll create 2D views. You're going to work a lot with that, maybe even in the engineering environment, when you guys get older. So this is where you can create those engineering drawings, and they look extremely professional, and they come in handy for, showing the dimensions, and maybe information that you might want to share with people that you're giving this piece to. So overall, Fusion 360 is an end-to-end product development platform. Like, you can start from beginning to end with it. You create your design, and then you bring it to life, maybe through CAD or CAM, or the CAM workspace. It basically allows you to do everything that you might want to do in a CAD program that you'd want to, like from beginning to end of the creation of your product. So basically, other CAD softwares don't necessarily have rendering maybe in their platform, but Fusion 360 has. You can design it, you can render it, you can animate it, doing it all in one place. So it makes it extremely easy, rather than maybe swapping different programs back and forth just to get what you want. So now I'm going to go over the interface a little bit here. So we have our application bar. Right here, you can see the 9 dots. That's going to open your data panel. We'll go into that a little bit later. But this is where you kind of save your file, or you open a new file, and you can undo and redo. Next is our profile and help. So this is where you can access your preferences, you can look for more help online, and you can see updates from Fusion 360. So if you were to click that little question mark, that would take you to the help. And so if you were maybe looking up how to see what a different tool, or looking for a certain tool in the program, or seeing what it does, you can search there. And it also links to Autodesk website, so you can find more information there for if you're looking for more help. Next is our toolbar. So here you have this big design button. So this is where you swap in and out of each workspace. So you have your design workspace, your generative design workspace. This is where you're gonna click to change throughout that. And then here, you kind of work left to right through this toolbar. So you kind of create your sketch, and then you work on modifying it, maybe assembling it and such. So these are the tools that you'll be using to design whatever you need to design. And we kind of have sub workspaces in between that too. So your solid, surface, sheet metal, and your other toolings. Next is our view cube. So that's kind of how you change the different, I guess, way you see your piece. So if you want to look at the front, top, right, we're working on an XYZ axis, so you can change it there. And then we have our browser. So this is kind of where we have most of our information stored. You can see different files and stuff. We'll go into that in the next slide as well. And then next is our canvas and marking menu. So if you were to right click while you were using Fusion 360, if you were right click in your workspace and hold it, you could see this little menu here. It's kind of like a shortcut menu almost. So if that's easy for you, you could use that, or you could use shortcuts, however that works. And then our timeline. So our timeline's kind of just literally a timeline of how you created the piece. I'll talk about that in the next slide as well. And then our navigation bar and display settings. So your navigation bar, these are going to be the tools that you use to navigate your piece. So you can zoom in, pan, zoom out, rotate, anything to change your perspective on the your work that you're working on. And you can also change the display of your little workspace there. So if you wanted a grid or a dark background, you can change that. So your browser and timeline are some really big components of Fusion 360. In the browser, what we have is kind of our top level data. This is where you're going to see your joints, your components, different assemblies, and you have that information there. You'll see your origins and different planes that you might have. And then your timeline, it kind of goes more in depth of each component or joint that you have or your assembly that you have. So it's going to show the exact steps and tools that you used to create that piece. And you can go back and forth through that timeline. So maybe you made a mistake somewhere. You can go backwards and go maybe change it or view it with that mistake or something like that. You can also double click any one of these pieces and go back to edit that feature. So yeah, you can also press the play button and it'll walk you through the visual of how you created, your piece. So it'll show you those exact steps. Here, this is the data pin I'll be talking about. So, oops, sorry. So if you were to click those nine squares in the corner, top left corner, it will open your data panel. And so in your data panel, this is where you're gonna have all your projects stored. And within your projects, you'll have your file folders. And this is where you're gonna basically be storing your files of your project. And with that, you can share those files with your teammates, whoever you might be working with, whoever needs to see your project. You can share that with them, and they can see it, and you can see what they're seeing, what they're viewing. And you can see we're in Team Dan. You can change what different team you might be on, and it'll show the different projects within that team. So as I was saying, you can share your projects with other students, your teacher, whoever, and so you can see who's going to be working on each component within your project. So when somebody's working on one component, you might not. Fusion basically says this person's working on it, and so you can't edit it. So until that person basically closes it or saves it, you guys are restricted from editing it, so that there's no overlap of design improvements or whatever you might be doing. And so it'll let you know. So maybe somebody made a change. It's going to notify you if your assembly is then out of date. So say you changed one of your components and you go back to the main assembly, it'll have like a little error sign, and so it'll say update this, and you can see if it'll have a design conflict or not. So basically here, this is what it's going to look like. So here we have a build assembly, and so you can see in the browser here, this is where we have all the different components, and so you can see your team members in each component and who's working on what and who has what open. So it's really clear on that. And I'm going to hand it off to Jake now, and he's going to walk you through the demo.
All right, thanks, Serena. So so we gave you guys a little bit of an introduction there about what you can kind of expect from Fusion 360. Well, let's actually get into some modeling now. Let me go ahead and share my screen. You guys do have the option. We prefer if you followed along with our demo where we're going to be building this jack stand, which means by the end of this workshop, you guys will all have this model completed just as you're seeing here. If you prefer to just, watch along and kind of really focus on some of the steps, that's okay too. We will be providing the recording of this, so you can go ahead and, work through this and build this model a little bit later too. All right. So hopefully you have your Fusion 360 open, or you're going to go ahead and get it launched. In the meantime, let's expand just really briefly on some of the points that Serena talked about, and then let's go ahead and get modeling. So starting from left to right, we talked about our data panel over here really quick. So what we're seeing is a few projects. You also notice I have some pinned, which essentially means I have more projects in this, but here's a few that I'm just currently working on. Now, again, inside of Fusion 360, there are so many different ways to stay organized. And just a little tip again, just because you see me do something one way, or you see that my Fusion is configured in a very specific way, that doesn't mean that you have to follow, those exact steps. I highly recommend that you explore the software and figure out what works the best for you. So if I wanted to look at all my projects, again, I could just go to all projects on this little tab here, and any that you wanted to pin, you could just hover over and click this little pin icon. That's just how I stay a little extra organized. So I'll go to pinned, and let's navigate this a little bit more. So we have these projects. For this workshop, I have all my files inside of this Autodesk Design Competitions project. I'll click into that, and now we're seeing some folders. Well, let's go ahead and jump into the current year and our current project that we're working on right now at Delve. We're seeing some files here from past workshops and just a few other miscellaneous files. Here's a file that I used for the rendering. So once you have figured out where you want to save your file, whether you're putting that in a folder, a brand new project, whatever it may be, anytime that I open a new file and save it, whatever I have open on my data panel, that's where it's going to save. We can also see, we talked about design reservations earlier. You can see that I have this file open right now, and I could be editing it. So if any of these other people, which if I go over to this people tab, all these people that we're looking at right here have access to every single one of these files. I'm working on this one right now. I've reserved it. So when somebody else opens up this project and navigates to this folder, they'll see that I'm going to be working on this right now. And then when I'm done, I'll go ahead and save. They can look at my version, see if I gave it a little definition, and continue working from there. One more thing that I do want to touch on before we go ahead and get started is our preferences. So if we go from the left to the right side of our screen, on the top right here, there'll be a little icon if you set a profile picture. If not, it should just have your initials. Go ahead and click on that. Click on preferences. And the number one thing that I get asked is, hey, I learned SolidWorks before this, and I really like how my pan, zoom, and orbit works on my mouse. So I want to set mine to that. Well, it's going to default you to Fusion 360, but if you're somebody like me, I was more comfortable with SolidWorks, and I like to just have one configuration that I customize all my CAD softwares to, so that I know whenever I open up a new CAD software, it's going to use the same mouse command, so I'm not confusing myself in any way. So if you come from any of these other CAD softwares and that's what you're comfortable with, you can go ahead and set that. Now, I also do recommend just taking a quick second to kind of scroll through some of these settings. There's even a little preview features at the bottom here where you can kind of be part of the beta testing group for some stuff that we're working on. However, this general page is going to house most everything that you need. And again, so the pan, zoom, and orbit is probably the one thing that if you're going to change anything before you start modeling today, that would be it. Let's get out of that menu. And let's see what else. Well, another cool thing before we open our file is this timeline down here that Serena talked about is pretty cool. Now let's walk through a couple examples that we have a file that's got some parts in it, and you can see this is all the steps that it took me to create this file. Now, if I click this little play button here, you can actually get a little preview of all the steps we're going to take to model this part today. starting from 2D sketches, going to some 3D geometry, modifying that geometry, adding all sorts of components and features, and eventually we have our completed assembly here. All right, so the other cool thing about our design timeline, which we will get into a little example later, I can literally go back in time. If I just drag this bar back, which I'll just drag it back to a random spot. Now I am back about halfway through modeling this part, and I can make any changes that I needed to make at this step, and then go ahead, just bring myself back to my final product, and everything will update. So I really like that about Fusion 360, that it tracks everything you do, and that any decision that you make is not concrete. It's not fixed forever. For example, I could find this extrude, right click, and edit this feature. And now I can modify all my values. Again, I'm back in time, and I can fix my mistakes, change my values. Maybe manufacturing, the engineering team comes back and says, hey, you need to make a couple little changes. It's super, super easy inside of Fusion 360. But you might not know what any of these icons are or what all that is. So let's go ahead and get into it. So we are going to be working, if I just jump back over here really quick, we have this PDF for all of you that's going to walk this through. If your professor didn't provide it to you yet, we will make sure that they get it to you. Otherwise, you can just follow along with all the steps that I'm doing today. I will be walking through this exactly as you would. So you'll have this as well as the recording from our workshop today as two resources to help you create this part. So let's go ahead and jump back into Fusion 360 and let's get into it. All right, so first things first is I'm going to create a new file. I want to open up a new one. And cool thing I like about Fusion 360 is it's very intuitive. This is just like a web browser where I can just open up a new tab, or in this case, a new design. And we have a we have a blank canvas. So this is a completely blank file that we can start to work with. A habit of mine is, and just kind of general good practice, is I'm going to open this up and I'm going to save it. Now let's call this the workshop, and let's throw today's date behind it. We'll show you where it's going to save it. I'll click on save, and then we should see it pop up right on the bottom of this list here. Now you can see all of these saves have a version number next to them. So every time you save, it's going to create a new version. If you open up that folder, you can even open up these old versions. For example, if you made some changes or a teammate made some changes and you want to go down a little bit of a different path, you can just go back, open up your old save. And again, this is all stored up in the cloud. So, no longer are the days of having to save multiple different files and our multiple different file names on a USB stick that eventually will get broken and stop working. All of this is up in the cloud. So you could sign on to your Fusion 360 account from halfway across the world, and you'll have all of your files at your disposal. So again, another really, really cool thing about Fusion 360. We just have version 1 on our file, and there's no sort of preview because we haven't made anything yet. So let's jump into it. The first thing we're going to do is we're going to make a new component. Now inside of Fusion 360, there's a couple common things you'll be using are bodies and components. Now again, these are just organizational tools. And let's go ahead and do a good example of what that is. Now, if I right click on this here, I can create a new component. I could also go into my create menu and find new component, the first option. I'll go ahead and click that, and it's going to ask me for a name. Well, I'm going to call this the piece subassembly, and I'll click OK. We see a new component pop up here. A component is the icon for it is going to be this little white cube here. And let me jump back over to this file, and let's make sure that you understand what this is. So when you have a assembly of multiple components, we're going to have a few of those in a second. You can see there's a few cubes stacked right on top of each other. If I open up this subassembly of multiple components, we see we have a few components inside of here. And if I open those up, go into my bodies menu, we can see we have a body inside of there, which is these white cylinders. So again, don't stress too much about bodies and components. This is just an organizational tool, and it's all part of planning, right? So this isn't necessarily a one size fits all thing where I open up a new file and I automatically make a new component and I call it base subassembly. This will change for every single part that you're doing. I just happen to know in planning before that, okay, well, I'm probably going to start by modeling the base and then work up and in from there. I know my base is going to have a few parts on it, and I want to have all those parts nice, neat, and organized under one little folder. The other cool thing, if you organize well, you can toggle things on and off very easily. And again, it's just more organizational tools. Now, this is going to come in very, very handy, especially since you guys are working as teams. You don't want to have your teammate spending a ton of time sorting through here and trying to find what they're looking for. Everything should be nice and neat and organized. I'm going to go ahead and close my data panel now so I can maximize my workspace. And under our base subassembly, I'm just going to right click, create another new component, and let's just call this one the base. For anybody who's here live, feel free to unmute at any time you have a question, or you can go ahead and type it in the chat. Serena will either answer it there, or if it's something that could benefit the group and we should answer it live, she'll just go ahead and unmute and ask me for you guys. All right, let's get to sketching. So to create some geometry here, we're going to start from a 2D sketch, just like you would have a piece of paper on your desk and you're going to start drawing. I'll click on my create a sketch icon. I could also go open up the create menu and go to create sketch. Another cool tip about Fusion 360 is if you don't know what any of these tools do, all you have to do is hover over them and it's going to give you a little tooltip, which is going to be a little bit of a text to kind of define what this does and how you can use it, and a visual aid to kind of back that up. So when I was a new Fusion 360 user, one of the first things that I did is I went and I opened up all of these menus and I went through and I read what these did and looked at the little example. This helped me. The analogy I like to use is I got to put all these tools in my toolbox. So the next time that I was going to go design something, I had a good idea of the direction that I could go in to get that done. We're going to start by creating a new sketch. And then it's going to go ahead and prompt us, hey, what plane do you want to sketch on? Now we're just looking at an XYZ coordinate axis and the associated planes. I want to go ahead and sketch on my XY plane. And again, I like to think of this as just makes sense for me if I had a piece of paper on my desk and I'm just drawing straight onto that. So I'll click on this plane here, the XY plane, and you'll see it'll go ahead and snap us into a view that is perfectly top down on our plane here. A few other things changed. We have a new menu that popped up that is our sketch menu. We went from solid, and it's going to open up this sketch menu. And there's also a little sketch palette on the right-hand side. So anytime we're going to use these commands, typically something will pop up on the right side of your screen. It might prompt you for something, or in this example, it's just giving us some more tools that we can work with. We're going to go ahead and start by creating a rectangle. We want to create a center rectangle. We can see in our toolbar here, we have a 2-point rectangle that will do a rectangle like that, but that's not necessarily what I want. I want this rectangle to be centered about my origin here, where my X and my Y axis are intersecting. So if I open up my create menu, let's see what else is in here. Well, I have a 3-point rectangle and a center rectangle. Now the center rectangle is the one that I want. So let's go ahead and take this center rectangle. I'm going to hover over. I'm going to get close to my origin, and you see when I get real close to it, this little light blue box is going to appear around that. Now, anytime you see these kind of light blue little features and shapes and stuff, that essentially just means you're referencing something. So right now I'm referencing my origin. And you also see the little text that comes up that says place center point. Okay. I'm going to go ahead and left click once, and now you can see I have control over making this rectangle any size that I want. We're going to want to make a 1.5 inch. I'm going to click on tab to go to my next dimension by 1.5 inch square. I'll press enter. And we have a 1.5 inch by 1.5 inch square. Now, again, before I said there are so many different ways that you could get to this step. For example, let me just double click and let me actually just control Z. That'll be easier. I can get rid of these shapes. So I could have done so many other things. I could have gone to my rectangle and let's add some dimensions manually. So if I go to my center rectangle, open this up, and I'll just put this at a random shape. And Matt, I see you have your hand up. Let me get to you in just 1 second. I could click the letter D on my keyboard or just open my create menu and go to sketch dimension. Now, any of these icons that you see a capital letter next to means that that is binded to a shortcut key on your keyboard. So for sketch dimension, I know that I don't have to come into this create menu and click on dimension. I also don't need to come up here and click on sketch dimension. I could just click the letter D on my keyboard and it's automatically going to start using that tool. So that's just something that you'll kind of learn over time. Now, all I have to do is click on any of these lines, click again, and it's going to say, okay, this is 3.26 inches. I want to make that 1.5. Click on enter, scale down, and we'll just do the same with the side. Matt, do you want to unmute and ask your question?
Yeah, I was just curious. Mine is defaulting to centimeters. Is there a way to switch it to inches?
Yeah, good question. So anytime you open up a new file, it's going to go ahead and open it up in whatever units that you set default. Now, if you have a project, let's say for this one, Matt likes working in centimeters. That's what he works really well in. But for this project, we're going to use inches. Under my document settings right here, we can just open up this tab and it's going to have our units here. Now, if we hover over that, so yours should say centimeters, this little kind of pen and paper and a ruler pops up and it'll say change active units. If we click on that, we're going to get a menu that pops up on the right-hand side of our screen. And from here, you can toggle between the different units. So you can set yours to inches, click OK. And there is also another little checkbox that comes up here that you can set as default. Now, this is the quickest way that you can do that. That means that anytime you open a new file, let's say you always work in inches, well, every time you open a new file, it's going to be in inches. You could also do that from your preferences if you open up your preferences. And you can go ahead and I forget exactly where it is in here. Here we go, default units. So you can go into all of your spaces and select what your default units should be. Does that answer your question, Matt?
Absolutely, thank you.
Awesome. All right, so we should have this 1.5 inch by 1.5 inch square here. So we got some 2D geometry. Let's make it 3D. I'm going to go ahead and go up to this finished sketch icon on my top right, which basically just means, hey, I'm done drawing. Now we're back into our solid menu. And again, in our design space under our solid menu, we're just making solid watertight objects. These are definitely going to be the most simple. And this is during your time during this competition. This is where you're going to be spending a majority of your of your time rather. We're going to go to this tool, which is an extrude. Now, again, we can hover over and see what this could do for us. We'll click on extrude. It's automatically detecting that I have one sketch and I have one closed, loop, or this square has no openings in it, which means that I can make it 3D. And from here, we're going to go ahead and just drag this arrow and check it out. So now I can just drag this to whatever value I want, and it's making a 3D cube. We're going to take this and we're going to input a value of -6 inches. I'm going to zoom out a little bit so I can see my entire part here. And we also want this to taper out at 20 degrees. So again, we've gone to extrude. It's given us a little pop-up on the right side, which is going to ask us, some action items for us. All we want to do is bring this down 6 inches, and we want to make it taper out 20 degrees. And you're going to get something that looks like this. We can just leave this as default. You can see it's going to create a new body, and we'll go ahead and click OK. So now you should have something that looks like this. I want to go ahead and round the edges here so they're not so sharp. So I'm going to go to my modify menu. So we just started from a sketch, created some 3D geometry, and now we're going to modify that. So I'll go to modify. I'm just going to go to fillet here. And I'm going to go to my part, and I'm just going to hover over and grab these edges. As you see, once I hover over, they're going to turn black. I'll select it. Now I have a couple options from right here. I know I have another edge on the back side here. So what could I do? Well, I could go ahead and orbit around and select this line here. I'm going to use my home icon right here just to go back to my isometric view. And let me actually rotate into this one so I could show you. The cool thing about the fillet tool is you can actually just hover over and select through your part. So I don't even need to go rotate around. I could save myself some time, just hover through my mouse. Eventually it's going to find where that edge is. I'll click on it, and let's add a 1/4 inch fillet to these. So the little box comes up, it's going to say to specify your radius value. We're going to make that a 1/4 inch. I'll go ahead and just click OK or click Enter, whatever you prefer. And this is our updated geometry. Again, something that I hinted on there, if you have rotated and let's say you're in a view and you just can't see anything and you just need to kind of have a little reset, your view cube up here will help you out a lot. So there's a home icon. Now, if I click on home, it's just going to bring us back into this like 3/4 view that we can see our part. Now you can also use the cube here. You can see that's a right plane. This is a front plane, and this will go ahead and snap you into a view. And you can also use these corners, the little ledges of your part here. So it definitely comes in handy. So just kind of click around on here, see what it does. There's also a little hidden menu kind of that can pop up here. I really like this visual style, perspective with orthographic faces. If yours has defaulted to orthographic per se, you're going to not get any perspective distortion, which again, I will change this around based on what part that I'm working on. For this, I could definitely just leave it in orthographic mode. I wouldn't want to leave it in just perspective, but I want to have it lock into an orthographic view when I go into my faces. What does that mean? Right now, I'm seeing our part here, and we're getting some of this perspective distortion. But if I go into my front plane, you can see it'll go into an orthographic view. Now, if I change from this view mode to perspective, you're going to see again, I'm getting some distortion here. And if I need to, be very specific with some dimensions, that's not what I want. As you kind of get farther into messing around with some sketches and stuff, and we'll actually do some good examples where you would understand which view style you'd want to use. But typically, I'll just leave mine on perspective with orthographic faces. I'll go to my home, and the next step that we want to do is shell the body. So if I go into modify and shell, let's check out what this tool does. So it's going to remove material and essentially select a couple of faces that we want to leave hollow. So let's go to shell, and how can we use it for our object here? Well, let's take a peek back at the file again. I'm going to turn a couple of these off. And what do we have? Well, this base you can see is hollow inside, and it has this tube going through the top, which means the top also needs to be hollow, that a tube could slide up and down through it. Okay, well, we have our part here, so we can accomplish that. I'm going to go to shell, and it's going to ask for faces or a body. So I want to go ahead and select this top face here. Then I'm going to rotate under my part, and I'm going to select the bottom face. Now this is essentially saying, hey, I want these two faces to become hollow. It's going to ask us for a thickness. I'll go 0.25, 1/4 inch. And it's also going to ask us for a direction. Are you adding that 1/4 inch to the outside, the inside, if we add our value again, or both? We want to go ahead and add it to the outside. I'll click OK. And now your part should look something like this. An easy way to tell if you have done the operation correctly The top of this part here should have filleted edges on the insides and the outsides. Now, if you shelled to the inside, you're going to have 90-degree angles where these fillets are. So make sure this is kind of a very important step to make sure the rest of your jack stand is going to be correct. Now, let's say you accidentally did the wrong thing there and you want to go back and fix it. No worries. So commonly and in a lot of other CAD softwares, you'd have to, Control Z, click undo, and go back and just redo all of your steps. That eats up your time. That's eating up into your client's budget, whatever it might be. So how can we fix that? Well, we can use our design timeline down here. So I could right click on this feature, click edit feature. Now we are right back where we were when we were just talking about what these options did. So if yours was set to inside at 1/4 of an inch and you get this, you can just go ahead and change that to outside, click OK, and everything is going to update exactly to where you were. So you now have done less clicks and save yourself some time. So whether it's a school project or a professional project, saving time is always a bonus. Let's keep going. The next thing that we want to do is let's add some cutouts into the side here. We're going to create another sketch. And before we made a sketch on these planes. Now, again, these kind of see-through orange squares are what Fusion, that's how they represent their different planes. You can add these, you can do all sorts of stuff to them. But the other cool thing is you can sketch on any face. So we can see I'm not clicking anything right now. I'm just dragging along and I can sketch on any of these faces. Let me just grab this one right here. I'll click and you can see it's also going to rotate us into an orthographic view that we're looking perfectly on our part. Again, if we open up our view cube, it's going to say right now it's set to orthographic. So to make that triangular cutout, it's pretty simple. We're going to use our offset tool, which is under modify. And our offset tool is really intuitive to work with. You just hover over, you'll see eventually a little blue line will pop up. It's going to say, okay, you can offset this curve. Now there's just an arrow. So what does an offset tool do? Well, exactly here, whatever value you specify, it's going to offset that curve to. So let's bring this in -1 inch. And we're going to get the triangle with 3 nice points on it. I'll click OK. And we can see what we have here. I'm going to go to finish my sketch. Again, I'm done drawing. I'm ready to start modifying my part here. We'll go ahead and do another extrude. Now, before I click this icon, but if I open up my create menu, we can also see that this is the letter E on my keyboard, the shortcut key. So I'll just click E and my extrude menu pops up. Now, I don't really need to modify any of these yet. I'm going to go ahead and grab this inside feature here. And again, I can pull it out and add geometry, or as soon as we start pulling back the other way, it's going to automatically detect the collision and it's going to say, okay, I'm going to cut a hole instead of adding some material. So we'll drag this back, and I could just drag this back to any old value, but I know my thickness of my part here is 1/4 of an inch, so let's just go -0.25. I'll click on OK, and now I have the triangular cutout in my part. If we look back here, I want to round these edges, make it look a little bit nicer. So I can do that. We're going to do another fillet. Again, we already used this tool once before, so we're just going to use it in a little bit of a different way now. I'll click on fillet, and I'm just going to zoom in, and I want to grab this edge right here. Now I'm going to grab all 3 at the 3 points of my triangle. And I'm zooming out. I need to zoom back in and rotate to find this one. I'll just click on my home icon to bring me back to here so I can see exactly what I'm doing. And let's just do, how about 0.375? Need to double click so it knows I want to enter a value, 0.375. Cool. Looks like a good radius. I'll be happy with that. And I'll click OK. So now we can see we have this nice radius cutout, but we need one on all these other faces. So you might be thinking, oh, great, I have to go do a sketch on this face and do the cutout and fillet it. Then I have to go do a sketch on this face and make a cutout and fillet it. And that takes a ton of time. So there's another cool tool that you can put into your toolbox when you need to do a feature like this. So if I know that I want this to be on all 4 sides, we can use a pattern. So if I go into my create menu, scroll down to pattern, we're going to see there's a few different types. For this, we want to use a circular pattern. So let's look at our example here. Our example is saying, hey, it's going to go ahead and duplicate a feature, a body, component, whatever you specify, around a circular pattern, around an axis. So let's go ahead and apply that. Let's click on circular pattern. Mine has defaulted to features, and that's what we want. Yours might default to faces. In that case, we don't want to duplicate just a face, right? A face is just this real thin surface right on the outside here. We want to do features. Then I'm going to go ahead and go down to my design timeline back here, and I'm going to click on that fillet that we did to make those edges nice and round, and the extrude. And now you can see both of these are highlighted blue. So it's saying, okay, I've told it the 2 objects, the 2 features that I want it to pattern. The next thing it's going to ask me for is an axis. So I'll click on this select icon. And the original, right, so we made a center rectangle in that very first sketch we did. Now what that allows us to do is use our default origin for a ton of really, really good things. And the cool thing is I can just grab my Z axis right here. And if I rotate around, you can see the little preview that it's giving us. Okay, so this looks like what we want. The only thing that I want to go ahead and do is up this quantity to 4. Now you can see there's a preview of what the cutout will be like on each face. I'll click OK. And we have 4 perfectly even cutouts. So again, that's kind of just a, hey, I'm telling you, here's this tool and use it, but it's all something. So the next time that I have a project, maybe it's like this example that we're looking at here. You know, if I'm working on like a hub for a car and I need to do the perfect bolt spacing for a specific, that's how I could do this. All right, let's go ahead and it's a good time to save our file, especially if we haven't saved it yet. I'll go ahead and click on my save icon. Now, every time you save, it's going to ask you for a little version description. So this is just a little note for you or your teammates. I would recommend adding these because it can help you stay organized. So I'll say I completed the base. I'll click OK. And it's now saved. All right. Let's keep going. So the next thing we need to talk about is we're going to have a bunch of parts in a second. If we look back here and I turn this stuff back on, we have lots of parts, and we even have some moving parts that can move up and down, that can rotate. So we need to essentially tell the software, here's how to interact, you know, with these 2 parts. So the first thing we need to do, and again, this is something that right now it's just going to sound like, hey, do this. But as you get a little bit farther into testing out Fusion 360, it's going to make sense. We're going to work with joints. Now let's look at our preview here. Joints is essentially just defining the motion relative to 2 parts. So we can see on a joint here, our example is we have a few parts that are just kind of floating out in space, and I need to bring them together how the assembly will look, you know, as it's built. We have another option just called an as-built joint, and we're seeing our example here of this little utility knife. This is basically saying I've designed everything exactly in the place that it's supposed to be at. Now I just need to define the motion between these 2 parts. And we're going to use both of these today, and you're going to be able to understand them a little bit more. The first thing we want to do, if I go out of here, we can see that if I click and drag, I can drag this around my workspace wherever I want it to be. Now, this is just dragging out to a random spot in space, and we want everything to stay, I'll use the term grounded around one feature. So what I'm going to do is I'm going to go into my assemble menu. I'm going to go into as built joint. I'm going to navigate over to my browser here. I'm going to click on the base. And then I'm going to click on my top level component here, which is just going to be whatever you've titled your file. I'll click on that. It's going to give us a couple other things. It's going to say, okay, what joint type is it? We're going to expand on these in a second. Let's just leave it default as rigid. There's also an animation. This will make a little bit more sense with the couple next joints that we're going to do. But it's essentially just going to shake it around and say, hey, this isn't going anywhere. I'll click OK. Now, if I come in here, I can't click and drag this around anymore, which means it is stuck right where it's at, which is what we want for our future parts. Again, if I come back to this file that's completed, I can't click and drag any of these parts. These are all, stuck together how they would be, whether this would be a welded assembly in real life, but I can move things how they should. For example, this inside tube here and this pin. All right, let's keep going. The next thing we want to do is create a new component. So the first thing I want to do is activate this component. We haven't really talked about that yet. So let me go back to this file again really quick and open up my base subassembly. And let me close some of these folders. And so every time that you have a component active, you'll see every component's going to have this little icon that comes up next to it. It says activate. Whichever one's active, we can see my top level, meaning everything under here is I'm working on right now. It's going to have this little dot inside of it. For example, if I activated the base, you can see it's just going to kind of help me visually focus on just this part, and everything else is still there, but it's out of my view sight for the most part, and I'm just working with this base. Now that means that everything that appears under here, bodies, you can see we even have the decal of the Autodesk logo, all of that will fall under this because that's active. That's what I'm working on. If you're in school and you have like a manufacturing lab, right? And you are working on a lathe. Let's say that's your active component. And on your lathe, you have the part that you're working on, you have the tools that you're working with. Now, after that, you go over to the mill. Maybe let's pretend this is our mill. We'd go over to here and we're just working on that. Now we could take the same part from our lathe and go over to our mill and work on that. But just think of it as I'm kind of walking to like a different workstation. And now I'm just going to work on this. I find that this helps me because I like to just focus on whatever part that I'm modifying. And then when I'm ready to kind of check out my final, the whole assembly is one, I'll go back to my top level component here and activate that. Just click on my home icon so I can see everything, and here we are. So back to here, I'm going to activate my subassembly. Remember my subassembly, we created this component to create multiple components under and stay organized. So I have the base, but I need to create the extrusion up, kind of like the top tube or the neck of the jack stand. So I'll right click on this after it's active. I'll click on new component. And I'm just going to give it the name, let's call this one the top tube. I'll click OK. We can see again, we've activated a different component, which it automatically does when you create a new one, which means that the opacity got dropped super low on this. So it's still here. I can even still reference the geometry, like this top face we're actually going to be using in a second, but I'm not necessarily focused on it. I'm focused on the next part that I'm making. So then the next thing that we want to do is we want to create another sketch. And we're going to create a sketch on this top face right here, the one that I had just previously highlighted. You'll see it'll highlight blue, snap us into our orthographic view, looking top down on our part, and we can start to work with some of this geometry. So the first thing that we're going to do here is we're going to use our offset tool again. We're going to offset this inner edge here, and we're going to bring it out so we can see this is now a negative value. If we go in, it's positive, and out, it's negative. We're going to go negative 0.5. I'll click on OK. And we can see this is really close to our other feature here. We're essentially assuming that this tube that we're making is just a cut section of some off-the-shelf 1/4-inch wall square tubing. We've created our sketch. Again, I'm going to finish my sketch. I'm done drawing. I'll go to my extrude tool by pressing E on my keyboard, and I'm going to hover over and I'm going to grab the stuff that we just drew. I can drag this up, or I can just input my value of 3 inches. I'll zoom out so I can see what it looks like. That looks good to me. I'll click on OK, and we have our next part, our top tube. So I'm going to pause there for 1 second. If you guys have any questions, unmute. If not, we'll go ahead and keep going. All right. So the next thing we need to do, if we look back at here, is if I turn this off by just clicking a little eyeball, we need to add a hole for our pin to go through. Let's do that. So I have my part here. I'm back in my home view, and I want to add a hole to the side here. Well, I can go to my create menu, go to hole. Again, there's a lot of different ways you could do this. You're seeing me do it one way. The kind of like golden rules is typically like 5 different ways that you could probably get to the same result. So you're seeing me do it one way, but by all means, explore. I'll click on hole. Now it's going to go ahead and give me a new little menu up on the right that we haven't really seen yet, and ask like, where do you want to put this? What do you want to do with it? What type is it? Is it tapped? Is it countersunk? All sorts of things. For now, I'm just going to find this face right here, which is where I want my hole to be. And I'm just going to click in a random spot. I'll just throw it right there. So cool, that's up there, but that's not necessarily where I want it. I want it to be centered. So now what I'm going to do is I'm going to utilize my view cube. I'm going to click on my right view. You can see it'll snap us into an orthographic. Now I can just take this and click and drag. And when you click and drag, we see it now just added a little center point right here. It's going to disappear when I let go of my mouse. But all we do is click, hover over. It's going to snap to that point. After you get this in the right spot, we can even rotate to a little bit of a 3D view here so we can see. So what are we seeing? Well, it's drilling to a certain depth, and we can even see the drill point, our little 118-degree point right there. I want this to go all the way through to the other side because the pin has to go all the way through my part. So I'm going to come down, and right here where it says extents, we have it on distance, which basically means we're defining the distance that this hole is. Now, of course, I could just drag it all the way through to some random number and cool, through the other side, that's what I want, right? Sure. A better practice is instead of distance, we're going to select all. Now, when I select all, it's going to automatically calculate what that means for me, essentially, and say, okay, well, this is where this hole is going to stop intersecting with the geometry, so I'll stop there. The benefit of doing that is down the line, let's say that everywhere you wanted to go grab this off-the-shelf square tubing was out of stock, and you have to change it to a different size. Well, when you go back in your timeline and you modify that size, when I have this set to all, it means that, hey, I'm going to update. And let's say we used a bigger tube. It'll go ahead and make sure that this hole is still going through all the way and everything is going to update correctly. That might be a little bit hard to grasp right now, but as you keep going in Fusion, you will have those headaches. It happens to every new user that you go back and change something and it tries to update, but something just isn't right. So this is just one of those good practice items. I can just go ahead and select all on my extents again, and it's just going to calculate that no matter what size I change this tube to. The only other thing that I need to do is go ahead and modify my hole diameter. Mine, this is the last hole that I made, so it's already set to 0.51 inches. Otherwise, go ahead and set your diameter to 0.51 inches. We're just making it a little bit bigger to add some clearance for a 1/2-inch pin. And we'll click OK. And check it out. We've got a hole through our part. Awesome. I'll go ahead and go back to my home view, and let me just activate the entire base subassembly again so we can see what we've made. And again, it's a good time to save our part, our file rather. I'll just say we added the top tube. Now, again, the cool thing about Fusion 360 being a cloud software, let's say your computer crashes for whatever, random reason. chances are you're not going to lose a ton, if any, progress. Next time you open up Fusion 360, it'll essentially say, hey, we detected that your computer crashed and you weren't able to save your file. Here's a backup of that file. Now it might be, 2, 5, 10 minutes before your computer crashed or something, but you never really have to stress about, oh my gosh, I forgot to save my file. Everything is already saving in the background. It's automatically stored up in the cloud for you. All right, so we're gonna do another joint again. So right now I can click and drag this anywhere. I don't want that. This is supposed to be a welded assembly together, so it would be one piece in real life. You see me click this button a couple times probably, but after I click and drag something and I want it to go back, this little position icon up on the top right here is how I can do that. Instead of position capturing, which means it's gonna stay right there, I wanna revert. And when I revert my position, it'll bring it right back to where I drew everything. We're gonna go into assemble and use another as-built joint. Remember, we're using an as-built joint because we've built this exactly how it's supposed to be. And what we wanna go ahead and do from here is we're gonna go ahead and grab our base and our top tube. We want to do another rigid joint, and so we don't have to do anything in this menu up here. We can animate it. Now you can see both of these are shaking together. I'll click OK. Now if I go and try and click and drag this, I can't, which means, hey, we told this piece not to move, which means if these are now, cooked together, I can't click and drag this either. This is another concept that takes a little bit of time to fully understand when and why and how to use these tools. So don't stress about it too much right now, but we're teaching you all of, the kind of general good practices. All right, so we want to go ahead and make another component, that inside tube that we're seeing here with all these pins. Let's do that. I'm going to activate my top level component here. This isn't necessarily part of my base subassembly, so I can leave it out of that. I'll right click on new component, and under name, let's call this the inside tube. Click OK. And we see another component popped up and it's active. All right, so we want to keep working with some of this geometry we have here. So let's create a sketch. We'll create a sketch on this top face right here of our tube. Now what we want to do is we want to go ahead and offset this inside edge right here. We want to bring this in 0.1875. Everything looks good to me. The preview looks good. I'll click OK. And again, I am done drawing, so I'm going to finish my sketch. And now let's go ahead and make this inside tube. So we want to go ahead and just extrude this part of our sketch here. So I'll extrude, grab that, and we want to bring this down. We want to bring this down 9 inches. So I'm going to put -9. We can see, okay, that'll bring it right to the floor, and we are good to go. So I can use, just leave the rest of these as default. Don't need to do anything there, and click OK. The next thing we want to do is we want to add our first hole to the side of this, and then we're going to use a different pattern again to make all the holes. So for clarity, I'm going to go ahead and turn off my base subassembly. So this is all I'm looking at. Again, this is part of the organization. I can turn both of these off with one button click. That's kind of how I like to measure myself in CAD. How many button clicks am I making to get to my result, and how can I really bring that number down? So there's a lot of different ways to get to this next step again, but we essentially just want to put one hole on here, and we want that hole to be exactly 1.5 inches down from this top part here. So here's maybe how I would do that. I would click on create a sketch. I also want to double check that I'm sketching on the right face right now. Now this face should be the face that we did our previous hole on. So I'm going to turn my base subassembly on really quick, and yep, we can see it right there. Perfect. So I'm going to click this face, We're sketching right here. And now we need to tell our hole to start, and that's going to be 1.5 inches from the top here. So what I might do is I might go into create, and I'll grab a point. So all this is going to do is creating the sketch point. I'm going to hover over this line here. And again, we talked about it a little bit earlier, but when you hover over and something highlights this light blue, it means you're referencing it. Now, if I go over, a triangle pops up, which is our kind of symbol for the midpoint. So what this is saying is right where I'm going to draw a point right now is perfectly in the middle between this point and this point. And that's what we want. We'll give ourselves a reference there. Now I'm just going to drag my mouse down, and I'm just going to click at a random point. How about right there? I'll click escape to get out of my point tool, and let's add a dimension. So I tell this point to be exactly 1.5 inches from this top edge here, which we are going to use this point here to do that. I'll click D on my keyboard for dimension, click this point, our second one, and just drag this out to a random spot. And this is a little more than half what we want. We want to go 1.5. Click enter, and we have 1.5 inches. That means that this point that we put right here is exactly 1.5 inches from this top. Perfect. Also, if we turn on our base subassembly again, we can see that's exactly where we placed this first hole for the pin to go through. Awesome. I'll finish the sketch. That's all we need. We can now go to create a hole, and we can just click on this one that we just made, this little point here, and it's going to start using that. So we'll do the same thing that we did last time. We're going to change our extents from distance to all. It's going to calculate how far that's going to be. And I can just kind of come in here and double check. Okay, my diameter didn't change. Everything looks perfect. I'll click OK. Now, again, we can see we have a hole that goes through both sides. All right, 2:45. Let's keep things moving. So the next thing we want to do is create a pattern of holes going down this. So again, if I look back at this file, so these holes are exactly, I believe the value is 1 inch separated apart. And if I even bring this all the way up out of our jack stand, we can see. So this is our next goal. We have one, but we need to pattern those down. All right. So under create and pattern, we used a circular pattern before, but let's use a rectangular pattern. So this is going to be a little bit different, but another really handy tool. We'll click on rectangular pattern, and let's see what it's prompting us for. First things first, right at the top, this should be set on features. For the features, we can do it a couple of different ways. I could come in here and just select this hole here. It's going to automatically detect that, okay, right before this, this user made a hole and put it straight through. I could also just come down into my design timeline down here and click this last hole feature that we did. The next thing it's going to ask for is a direction. No, this direction is just giving it a reference on which way it should make these holes. It doesn't know if it should make them right, up, left, down. You haven't told it where to go yet. So for a direction, we can use any of these vertical lines that are on the side of our tube here. I'm just going to use this one right here. Now you can see some arrows pop up, and let me just start dragging these down, and you can see, okay, we told it what direction to go. Now we just need to tell it where to place. So let's go back to our menu on the right here. Right now it's doing distance type on spacing, which we want, that's actually what you want. I believe it does default to extent. So if yours defaults to extent, change it over to spacing. Now we're telling it the distance between the holes. So our distance down here should be 1 inch, and we're going to tell it to make 6 full holes. We'll click on OK. And it's going to do its thing. And now if we rotate around, we have all of these holes for the pin, so we can adjust our jack stand into multiple different, 6 different positions. I'll pause there for a second again, unmute if you guys have any questions. All right, cool. Let's keep it going. I want to go ahead and turn this back on, and let's just make the top level assembly active so we can see what we got. All right, well, we have our inside tube. I can see it inside of there. But again, the issue that we're running into right now is that I can just click and drag this wherever I want. Now, we don't want that. I want to revert that position. Go back to this file really quick with exactly how it would in real life. It's going to slide up and down. So let's tell it how to do that. All right, so again, very important, your top level component is active again. Now we're going to use the standard joint instead of an as-built joint. So this one is going to move around a bit. And this tool, again, we could do an entire workshop on joints and all the different types and how you can use them. So don't sweat this part, just follow along the steps. I'm going to come and I'm going to find this face here. Now, if I grab this, this is the top face in our inside tube. And when I hover over it, you see all these little points come on. These are what we'll call control points, and saying, okay, you can snap to any of these. I want the one that's in the middle. If I try and take my mouse over, it disappears. So I'm on a Windows computer, so I'm going to hold Control. Now you can see it's going to lock its face in as my selection. If I let go, it's going to disappear. Hold Control, grab the center, click once, and then I'm going to go ahead and go to this outside face, and I want that same center point. So I'm going to hold Control and grab that. Now we can see that, oh my gosh, what the heck is it doing? The first things first is we want to go ahead and flip this, meaning stay in the orientation that you were in. Right now, all we've told it is that this face and this face are supposed to be even with each other. It doesn't know if that is in this orientation or this orientation. So we have to tell it, stay there. We'll go over to our motion tab. And right now it's set to revolute. Yours will most likely default to rigid. So we're going to use a revolute in a second. And, all these joints do all sorts of different things. You could definitely play around with them a little bit. We want our third option here, which is a slider. So if we click on that, you can see it gives us a little preview of what it is going to do. You could even change the axis if you have a very specific axis that you want it to go on. For example, let's set it to the y-axis and it will slide that way, but it defaulted to the z-axis and that's what we want. We'll go ahead and click OK. Now, if I go ahead and grab anywhere on my inside tube, I can click and drag it up and down as it would move in real life. Correct. So I'm sure you guys all remember PEMDAS from all of your math classes. There is an order of operations to follow here. So I selected the inner tube first, which is basically saying I want this one to move about my second object. So if I selected this one first and then selected my inside tube, I'm telling everything else to move about my inside tube and leave this stationary. But that's not what I want. Again, joints are very diverse. There are so many different ways. I still learn different ways to use joints every time I use the software. So, don't sweat it too much and just play around with it a little bit. We also have some great learning resources, different videos you can follow, cool little projects that make you use like every single type of joint. All right. So after your file is able to, move like this, let's revert our position. So we leave everything where it is, and let's give ourselves a save. Let's say we added inside tube and joint. Okay. Awesome. So the next thing we're going to do, where are we on time really quick? 2:50, all right. So the next thing we're going to do is we're going to go ahead and make this little cradle here, which will kind of cradle the axle. Looking at time, I'm going to go ahead and kick it up just a little bit. But again, you guys will have the PDF and this recording after the fact to finish your jack stand model. So the first thing I want to do is I want to create a new design. Again, this is just like you're browsing the internet. You just create a new tab. I want to go ahead and save this as well, just kind of my habit. And let's go ahead and call this the saddle. And I want to add the date behind it too. It'll show us where it's going to save. And if I click on save, open up my data panel, there's our file right there. And if we scroll down, we can see here's the other one that I'm working on, our main base file. All right, close this up and let's get going. Again, we've opened up a new file. So regarding the question earlier, let's say you did not change your default units. You would also, before you start going, make sure you change your units to inches. We're going to be working in inches right now. Let's create a sketch. We want to create a bit of an interesting sketch to get this kind of unique profile here. I'll create a sketch and I'm just going to grab this plane right here, my YZ plane. Click on that. Now this next sketch is a bit kind of random. You know, it's not something that is, let's just jump into it and I'll kind of talk through it. So the first thing I want to do is I want to give myself a point on my origin, and I'm going to give myself a point, a random distance up above that. I'm going to dimension that. I want this to be 0.25 inches. This is where I'm going to start drawing from. Now, again, this isn't something that you do for like every sketch. This is very, very specific to this part that we're going to make. So for now, just kind of follow along with what I'm doing. I'm going to go to my line tool, and I'm going to use this point to start here. I'm going to click once, and again, we haven't used our line tool, I believe, yet, so this is what it's going to look like. It is going to have an angle and a distance. We want to go over, just perfectly horizontal, and I'm not even going to worry about the dimension or anything yet. I'm just going to go ahead and click, and I'm going to click and hold, and let's check out what that does. Let me actually do a quick example really quick. Our line tool, we can just click and drag and you know, click and do all this together and eventually come together. And now we see this has this light blue infill, which means it's closed, which means we could extrude it if we wanted to. I'll Control Z, get rid of these lines. The other feature the line tool has built in is I can click and hold on this one, and it's going to start making an arc. Again, this is kind of like a very specific tool that you use for specific situations, but it's great to know it's there. So I can make an arc, and again, I can, you know, go through and do all sorts of kind of wacky things. All right, let me Control Z, get rid of those, and let's make our actual sketch. Again, I'm going to click once, drag it out to a random dimension, click and hold. Just make an arc that's roughly that shape. And I'm just going to make a line like that. I'll just go over to this little check mark and I'll click that, and it's going to stop the line. Now, this isn't the shape that I want. So let's go ahead and add some dimensions. So I'll use my dimension tool. I'll click from, I'll click on my dimension tool and just grab this whole line right here. And I want to make that 3 inches. You'll see it pushes everything out. There's not necessarily a right order to do this in, but the next thing I want to make sure is I want this radius to be 1/2 of an inch. Okay, kind of modified that up a little bit. I want the angle between this line down here and this line here to be 110 degrees. Another really important distinction that is a bit hard to see right now is that this line is not tangent to this arc. We can see this little constraint here, and we haven't really talked about constraints yet. Do this big menu up here called constraints, and let's do a quick example to kind of get a basic understanding. If I draw a line, I have these 2 lines right here, and I want this line to be parallel with this one. Well, I could go to my constraints, find parallel, click my first line, click my second line, and now this line is parallel with this one. And we see these little gray icons pop up, meaning that, hey, we've added a constraint. Let me get rid of these, just delete key, and we can zoom in, and now you're probably saying, oh, there's all sorts of them. There's one here, there's one here. We want to add another tangent constraint. If I go to tangent, this line to this arc, and it's just barely modifying it there. If I kind of come in and let's do a more drastic example like this, I can use tangent here, here, and we can see it's going to make that tangent about my arc. I'll get rid of these, and let's come back, and I only need to do one more dimension. I'll click on D. I'm going to grab the top of this point, and yeah, I'll grab this right here. So I want to essentially tell it how high it's going to go. 1 inch. It'll shrink the line down. And let me go ahead and just pause on these dimensions really quick. So if you're following along still, you can catch up. Again, if you have any questions, go ahead and ask now. All right. So the next thing we want to do is offset this. I want to offset this line segment that we just made. I want to bring it in 0.25, quarter of an inch. The next thing I want to do is I want to connect this here. So that's closed off. And I want to make a line here, but I don't actually want this to be like a solid line and closing this off because I need to mirror this to the other side here. So another tool, if I click on this line, in my sketch palette, I can make it a construction line. Now, a construction line is just something that you can use as a reference. And we're going to use this line as a reference in our next step. We want to go ahead and mirror this over to the other side here. So we're making kind of a U shape. I'll go to create and mirror. For objects, I could go and select all these lines and go around. Another kind of pro tip is that if you double left click on any of like a long line segment, it'll go ahead and just grab the entire thing for you. That's something that I wish I would have learned sooner in Fusion. Would have saved me so much time. I'll click on mirror line. Now this is where we're going to use our construction line here. And if I zoom out, we'll see the preview. That's exactly what I want. I'll click OK. Cool. We now have this U feature. The only next thing we need to do is we need to give ourselves another line to reference off of. I'm going to click on my offset tool, and we need to have an axis to revolve this about, and that'll make sense in a second. Right now, I don't want to offset this entire piece right here. So I'm going to unclick chain selection. Chain selection is basically just meaning it's grabbing the entire line segment. I just want to grab this one individual line, and let's just bring it up -4 inches. So this is, and if we go ahead and click OK, it'll add a little dimension saying, cool, this line is 4 inches away. And I can also make that a construction line so that I'm not confused that it's actually like geometry that I was trying to make an extrude out of or anything. Let's finish our sketch and let's use a new tool called Revolve. Create, Revolve. It automatically detects that this is the feature that I want to revolve. And under Axis, we want to grab this. Now, yours will not default to this. Yours should default to this. And so you can kind of tell what the revolve tool does now, right? We're taking this, telling it something to revolve about, and it's going to make that shape. Cool. But we just need kind of like a U-shaped cradle here. So instead of 360 degrees, let's go to 30 degrees. And let's make that symmetric. I want 30 degrees on both sides. So I have this little kind of cradle right now that would cradle like an axle on a truck pretty good. I'll click on OK. And it's a good time to save our file. I didn't put a little description in there. I know that I'm just going to add a couple more parts and probably just one more save until I'm done. So let's see. Actually, I made a mistake at the beginning here, and that mistake was that I forgot to create a component. Not a huge deal. We can actually just convert something. So if I open up my bodies menu, I have my body one here. I can right click, create components from bodies. Now we see it says component 1, which I can just double click on and rename round saddle. So that was a mistake on my end. At the beginning, I should have created a component. People forget. I've gotten pretty far into projects and realize I've forgotten that, but you always have the chance to kind of reorganize and reconfigure with that if you right click on any body and click create component. All right, so we're going to go ahead and create another component here really quick. And let's go ahead and call this one inside plate. So we're just adding, if we go back to our main file, we're just going to add a couple little features onto this, and then we're going to go ahead and assemble everything together. I will create a sketch. Now we can see, okay, well, we offset this 1/4 of an inch from our plane here. This is where that's going to come in. I'm going to grab just my default XY plane. Under create, I'm going to grab another center rectangle, and we want this to be 1.125 by 1.125 square. So we'll do 1.125, which is our tab 1.125. Enter. Rotate out. Okay, cool. That's what I want. I'm going to extrude this down, and I'm going to extrude that down a value of -0.75, 3/4 of an inch. I'll click OK. And the next thing I'm going to do is just add some fillets to these edges. 1, 2, 3, and 4. And we'll just make these 0.625. Should be good. Yeah. Okay. The next thing we're going to go ahead and do is add the little plate that goes in the middle and connects these two parts. So I'm going to activate my top level component again. Right click, new component. We're going to name this the middle plate. Middle plate. Cool. We'll create a sketch. We're going to create a sketch on top of this part that we just made here. We're going to offset this. I need to chain my selection again, so I grab the entire outside part, 1/4 of an inch. Okay. Now let's go ahead and extrude both of these features here. I'm going to grab both, and we're going to do something new that we haven't done before. Instead of extent type, we're not using distance. We're not doing all. We're going to use to object. We're going to rotate around, and yes, it's kind of hard to see, but we're just going to click on this bottom face of our saddle here. And now you can see what that does. It's extruding this just so where it meets that. We'll click OK and activate my top level component again. And we'll go ahead and ready to save now. So I'll save, and I'll say, let's say saddle complete. So the next thing we're going to do is we're going to go ahead and add this to this file so we can complete our assembly, and we're almost done. I'm going to open up my data panel, find that file, which I have as a saddle on October 15th. I'm just going to, it's so simple. You just drag and drop into your file. It'll pop up. I'm just going to use this arrow here to bring it up. And I don't need to like try and put it right in the spot it's going to go. We're going to add a joint. So I'm just going to bring it up right there, and that'll be perfect. Let me go ahead and close this up. So the next thing we need to do is add a joint. And we have one object that's just kind of floating around in space. You know what? I missed a step that I just found out with here. So let's go ahead, and this is actually a good kind of teaching example. So I made a mistake in my last file, and I didn't define the motion between any of these parts, which means I am in here and I can just drag these wherever I want, and that's not good. So if I go back into my saddle, the way that we'll do it inside of here, I'll just right click on this, and I'm going to create a rigid group. Now, again, we can see it's just going to say it's kind of locking the relative position of the selected components, and they're treated as a single object. So I'll click on rigid group. It's going to just grab everything in my file. I'll click OK. Now, if I try and click and drag, I can't in this file. Now let's save, and I'll say added rigid group. All right. So when we come back over to our other file, oh my gosh, there's warnings popping up everywhere, and it's basically saying this is an out-of-date file, that you or somebody else has saved this file, which was referenced here, and that you need to update this before you keep going. Okay, the easiest way that I like to do it is just coming up to this little icon here, which is telling you, hey, this is out of date. I'll click on that, and it's going to go ahead and update. Now, we didn't see much happen there. I'll do another example of that really quick after we do our joint. But now we can see we click and move this, and it's going to drag us an entire object. So if we look at our part here, this face, when this is installed, should perfectly match with that face. It'll be a little bit bigger, but that's what's going to contact. So I want to go and add the joint. I'm going to zoom into here. I'll hold Control to grab the center point, move over to here, do the same. You're going to see that come down. Now we're only seeing the one object that we selected, and it's also still a slider. We want to make it a rigid joint. I'll click OK. You can see everything does come along with it. So now you should have a pretty cool jack stand that you can slide up and down. The next thing we want to do, again, for time, I'm going to go pretty quick on these last little few things. We want to go ahead and add our pin that goes through here. Now, another really, really cool thing, actually, before that, we can give it a quick save too. Added saddle. We want to go to Insert, and go down to Make Master Car Component. Now, if you're not familiar with Make Master Car, it's essentially like an Amazon and like one of the bigger suppliers for all things hardware and you know, business and manufacturing and stuff. So very cool place. I want to go to my search bar up here, and let me just search Clevis pins, enter, and I'll scroll down and just grab one of these bent pole Clevis pins. I'll go into my filters on the left side here. I want this to be a 1/2 inch diameter pin because that's what we've designed for. And I'm just going to grab this first one here on this list. Now, if I click on the part number, this is going to pop up, and you can download 3D CAD of all of their parts that they sell. So this is really awesome, especially if you're doing a project that involves lots of nuts and bolts together. You can go grab the exact bolt that you're going to order and assemble in real life and throw it into your CAD system. This will probably default to 3D SolidWorks. Change it just over to 3D Step and click on Download, and it'll throw it into our file here. You can see it's just in a random spot. I'm going to rotate over, and I just want to get this generally in the right orientation. So I'm going to use these little rotational bars, and I'm just going to rotate it so it's generally in the right spot. We want to add another joint here. This one's a little bit tricky, so kind of watch closely and then go after it. I want to grab just this little circle here. And I'll hold Control, and I'll grab the center point of that. And I'll come to my face here. I'll hold Control, grab the center point of that. And you can see it's just lining it up perfectly. And if we go into our motion, we'll select this one as revolute, which means it can revolve, because in real life, this pin can spin around. Awesome. So the only other thing that's really left is we can add an appearance and make things kind of look different. So if I click the letter A on my keyboard, the appearance menu will pop up. Now this is just where you can make things you know, look cool. We can say we have kind of a red jack stand here. So why don't we do that? We'll click on A. I'll just go through my library here. Just familiarize yourself with this over time, but I'm just going to go for a paint. And let me just go for gloss paint and red. Drag and drop, super simple. Now we've got a red jack stand. The other thing that we can do is if I go back to my saddle here, what if we changed our appearance here? I clicked A again, and let's do something crazy. Let's make this like brass. Polished brass, sure. And I'll just drag and drop 3 times. I'll give this a save. Now when I come back, it's going to say, hey, you need to update. I'll click on that, and you can see it updates to what I have in my other file. Very cool. All right. So let's that's all we have for our modeling. I'm going to pause for 1 second here and just let you guys catch up. I'm actually going to step out to the restroom for just 1 second, and I will be back. And when I'm back, we're going to go ahead and talk about some of the other capabilities of Fusion 360, some learning resources, and then open up for some questions and answers about this design competition.
Yep.
Awesome.
All right, sorry about that, guys. Okay, so let's keep going. Thanks, Serena, for bringing this up. So we want to talk about some of the other capabilities of Fusion 360. So we have an entire rendering workspace. So in the rendering workspace, we're checking out our jack stand here supporting an axle. This is where you can create, some cool kind of photorealistic images. It's also super, super quick and easy. So when you're working on a project and your client wants to see the progress or, wants to get a good feel for how the part or, product is coming together, you can send these, and I think it's really cool that this is integrated into one software. Serena mentioned earlier, this is an end-to-end product development platform, which means that I can design, I can manufacture, I can render, I can do generative design all under one software package, all under one roof, which is really, really awesome. If you come from other CAD softwares, or if you're in manufacturing and you have to go, bounce your files between a bunch of softwares and exports and file types, it's so nice having all this in Fusion. Let's go to the next slide. Animations. So this can be helpful, like if you're showing somebody how a part is assembled, how it's going to fit together. We're looking at an exploded view of our jack stand with the parts color coordinated. To the next slide. We can also, there's a slicer inside of Fusion for 3D printing. So you can just go straight from Fusion to your 3D printer. There is also an entire really, really cool manufacturing workspace where we can do all of our CAM and CNC operations. We're looking at a few different examples here. I really like the CAM workspace inside of Fusion. I think it is one of the best on the market. We can also do all sorts of different simulation. We've designed our part. Now we need to kind of stress test it and make sure that it's functioning as we want it to. So there's all sorts of different types of stress and FEA testing you can do inside of Fusion 360. Inside of that same workspace, you're going to find shaped optimization, which is pretty cool. It's similar to generative design in some ways, which we'll talk about in a second. But this is essentially saying, hey, I've designed this part, and I imagine that it's going to be under these, loads and constraints in real life. Tell me where I can remove some material and improve my model. We can also, of course, we have an entire drawing space. So anytime that you need to make technical drawings of your part, sending everything off to manufacturing, that is all under the drawing workspace. And then generative design. Now, this is one that I highly recommend you guys try out. This is one of the newest technologies that's taken over the world of CAD. So we talked about it a little bit earlier, and we're looking at an example here of we're feeding in an engineering problem, and we're using AI and cloud computing to solve it. And essentially saying, hey, I have access to these manufacturing types, these materials, take my model and, make it survive these stresses and these loads, and give me a cool design. And not only one, but it could give you 20, 50 different designs that you would have never thought of and never actually been able to really design. So what we're looking at, this is going to look pretty foreign. I definitely, loop back around to this after you have some more experience in Fusion, but we're looking at preserves and obstacles, which is a part of generative design. So preserves are essentially saying, hey, keep these parts and connect them. And obstacles is where I say, hey, you cannot build anything here. I need this space open. You'll go into constraints and loads. Again, this is just saying, hey, we're looking at structural constraints. In the top image, this is saying these 4 feet of our jack stand are going to be pressed against the ground. And on the bottom, we have a couple different load cases for the real world stresses that are going to be acted upon our parts. You'll go ahead and select, what materials you would want to make this out of, what type of manufacturing you have available, set kind of various goals and objectives for your design. What you're seeing on the right is just a quick little preview of, what the software is trying to solve for. And then after it's done, which is really cool, you just send it up to the cloud. It computes up in the cloud. It comes back and says, hey, check out all these different ways that we found success in building this part. And now you get to go ahead and sort and filter through. For something like a jack stand, you might want to find the lightest one, but also one that doesn't, is very, very strong. You might want to find one that you can cheaply mass produce that is, not maybe the strongest, but it's more than good. So generative design is really, really cool. I love using it. And the coolest thing is that it is completely free for you guys. So if you were a commercial user, if you had a business, then you were using Fusion 360, every time you went ahead and tried to solve a study, which we'll just think of as like the engineering problem, it costs you $25. And then every time you choose one of these results here that you like, it would cost you $100. But as students, that's all free.
Yeah. And so we have some learning resources here for you guys. We'll have this linked in the Discord, and we'll also send this slide deck to your professor. But basically, we have some more information about the different workspaces and, CAM, CAD, generative design, and we also have the Fusion 360 YouTube channel linked. So there you can go and click on a video and watch them, guide you through maybe a certain workspace or how to design something in CAD. And yeah. And if you want to reach Jake or I or any of the other ambassadors, we're on Discord. So if you scan this link tree, you can find the Discord there and click on that and just join. And then we have an Instagram, which is also linked. And we have some YouTube videos that we also upload. If you join the Discord, then you can see Jake has already, posted the workshop here actually. But to get to this view, you're gonna want to come to Welcome and Rules, and you're gonna want to pick up the student role and then the delve role, so you can see this channel because it's hidden normally. So make sure you check for any updates in there.
Yeah, I'll just add to that. If you're new to Discord, we're here to help you guys kind of figure it out. It's a great platform to collaborate on. And for those of you who are here live, and for those of you who are going to watch this later, this is a huge advantage to you guys on this project. You essentially have a direct line to us and all sorts of other talented Fusion 360 users at any time who can answer questions about Fusion 360. But also us, the Autodesk student ambassadors who are working on this project, we can also answer, your questions about the prompt and Delve and, them as a company and what they're looking for. So outside of class, outside of regular hours on weekends, you guys essentially have a direct line to us. And, that's exactly what we're here for you. We're here to help you guys have success through every step of this project. So get on there, interact with us, and we hope to see you there. Yeah.
All right. Now I'm gonna stop the recording, but answer some
Awesome.
questions.